Okay, so why Singularity? I mean, I already mentioned that. I mean, I need to say a few words before we even touch the keyboard. I mean, by the time I started with Singularity, I had enough of different variants of how to make containerization or isolation or things like that. So I was not really keen of learning something else. But as probably many of you colleagues just said, no, that's what you need. So I sat down, worked it out, and it's actually turned out to be really deal breaker for many of the problems I had. So this is copy paste, so I think they don't complain from the original Singularity web page some time ago. So probably they changed it, it's different, but the main messages that I want to send to you as well is about SIF. I mentioned it is Singularity image format. You end up with single executable file. This is really nice. If you set it up in such way, you can run, okay, it's only one executable, but I will show you the trick. You can run many binaries or programs inside the container with a small trick. But the file itself is compressed really with a large and good quality compression, SquashFS. If you're interested, I can say more about that one, but we will just keep it. And you will see base container image. I mean, they're mixing both already on the first line. You can sign it. So essentially you can guarantee that if you send it to somebody else, that's what or you put it somewhere shared. And somebody comes and say, I ran it, but it destroyed my computer or deleted my data. You might say, okay, let's start with, is this my container or not? So you can sign it and claim that actually it has not been changed, that you're the owner or the one who built it. If you build it from scratch, everything that you've done is documented, and there's an easy way to access that information. That's also in the exercises, just a little bit, so you can familiarize yourself. I can't comment a little too much on secure, but if they mean read-only is secure, yes, perhaps that's secure. Or perhaps they refer to something else. Easy to move, which is really advantage. It's a single file. You can find, I mean, countless methods how to send from your computer to a cluster, from one cluster to another, store it in Dropbox, fetch it from Dropbox. You can have it on the web page. Here I can make the first parallel with Docker. You have Docker Hub, which you need a Docker or interface that you can download the layers. And if you want the image, they need to be assembled together. In Singularity, you can upload to a regular HTTP server somewhere and just say, build or pull that image from the web, HTTP or HTTPS protocol, or FTP. For FTP, I'm not sure, but I think FTP works as well. It will just pull it and bring it, which is a regular download of a file, but for transparency or easy access, it's excellent. If you think it's awkward, it's not. NGI is distributing their container images this way, so it's brilliant. I don't know. Data is intensive workloads. It's, as I said, high performance computing is a little bit on par. If you benefit, then you're losing here and there. But if you're having I/O and you need only one node, it's actually, I see it as an advantage. So I hope I will convince you by the end of this workshop. Elegance, yeah, why not? Bridge the gap between HPC and artificial intelligence. Yep, I can show you about that one. Deep learning machine and predictive analytics. I'll just end up with these few lines, and if I don't forget, I will show you something that what I mean as well. Extreme mobility comes again with, I mean, it's a single file, compressed. You can distributed. There was ways before. There are still some of them available for free. I mean, probably if you pay, there are more options, but they become too expensive for a private pocket. If you have a project behind standing and paying the bill, that's a different story. Compatibility, that is a little bit to my view, or to the point where I stand now is a little bit exaggerated, but designed to support complex architectures and workflows, Singularity is easily adaptable to almost any environment. Some of you already experienced, if you have the newest Mac M1 and M2, you are not very lucky person with this respect. And the reason is how the containers are running. And it's in this aspect, it is not different from Docker. Your container should be properly built or targeted for the correct architecture. So Docker will require you to have a 64-bit machine, ARM, Intel machine, or things like that. So you can't escape that part. If you have an image that runs on AMD 64, unfortunately, you can't run it on an ARM-based machine like the new Max or Raspberry Pi. The same story with 32 versus 64-bit machines. And it is very much the same explanation with Docker and Singularity. Docker doesn't, or it's a layer above the kernel. So what you want and you need to have is a working kernel. Then that one steps on top of it and runs a Linux system. And this is the problem for Windows and Mac because they don't have Linux kernel. Windows did the solution a couple years ago with introducing Windows subsystem for Linux, especially the second version, which is a real implementation, which is literally really, really good Linux virtualization. You have a Linux kernel. This is where you can actually start running and building Singularity in probably for the first time better than Max. Let's don't diverge there. So it is the same story. You need the kernel. And that most of the times is exactly how many times you publish a paper. I have to exclude the IT department here, probably, IT people. But if you specify how you've done the calculations, you probably will end up like specifying the version of the software. If you have been using one of these BAM tools, some tools, or things like that, or if you've been using something else. But I haven't seen people specifying under which kernel you're running, operation system, barely. Those things are beyond what I'm interested in. And this is exactly, Singularity is, yeah, I mean, kernel, the reason for the kernel is to take care about the hardware. Here I have to, why I'm talking too much about the kernel. When you come to GPUs, that's the same story. Handling the GPU is not the kernel, but you have drivers, which is very close to be the kernel. But they have to be separated because you have different GPUs. That's the same story. You can't put the drivers into the container. They have to be running on the hardware. So your container relies on a running kernel, and then Singularity has an option to specify, access the drivers, or communicate with the drivers, so I can actually use the GPU. We have such examples. I will show you, not going into details and deeper than that. I can't see questions on the HackMD and chat, but I will ask if you have questions. If not, I will keep talking. I guess I will get you tired, but I'm aiming to get at least the first example running, and then we take a break. But before that one, I just wanted to tell you how to think about Singularity, because two misconceptions are actually affecting my way of thinking, and when I discuss that one with colleagues or with somebody who needs help. usually Singularity is promoted as a virtualization or isolation environment, which is true. But with this respect, it has nothing to do, or it's really far away from Docker. Running a Docker or virtual box or virtual machine, you have a capsulated operating system, and you have bare access to what is outside that machine. Of course, Docker and VirtualBox and all these tools, they have the ways how to mount external drives, folders, etc. But you're isolated, you start from isolated state. Singularity is actually saying, okay, that's a hassle. It's much more close with this respect if you think about Conda. If you create a Conda environment, you put your tools, you put your different versions, Pythons, not only, you could be Java, compilers, etc. But at the same time, activating the environment, you have access to the system files like tar, zip, or anything, as well as any binary that is in the path, $path with capital. Which means that if you have something in your home folder and that one is in the path, regardless that you're in the Conda environment, you have access to these binaries as well. Where that complicates things. Yeah, that's the problem. You assume that if you run the Singularity container, everything is isolated, but it's not. It is actually, I've seen that Singularity starts to clearly state or rephrase that it's not about isolation, but about integration. So you create an environment which is kind of isolated, but because it's integrated with your life or current environment, it kind of mixes, and that causes troubles. And I will immediately refer to one. If you use pip install in the user space in your home folder, everything ends in .local. If you start a container, you can have all the Python packages the way it is there installed, but the Python inside of this container is built the same way as it is on a regular machine. And that one is looking also in your home folder .local. And surprise, surprise, yeah, there are packages, there are libraries, Python modules, yeah, I will use them. So all of a sudden, you have more than what you have in the container. And let's say somehow the container works for you, you send it to your colleague, but your colleague says, no, it doesn't work. It could be because they didn't have something that you have in your home folder that you didn't notice when you're running the container, or the opposite, they have a different version or anything else that actually interferes with the environment. This one I will actually refer or talk about somewhere late at the end of my part, when I will just say, okay, here is a list of really key points that I've been collecting and I'm using myself. What problems you will face building environment with Conda, Python, some other tricks there perhaps. But what I wanted to think is like, with this perspective is very close to Conda environment, but it's a little bit better, I would say, in terms of isolation, because inside the container, you don't see anymore the system tools. So you can have rsync, newer version. Well, you can do these tricks also with changing the order of each folder is in front of the path. But this gives you the option that on Ubuntu 22, I can run Ubuntu 16 or vice versa. Okay, I'm not sure. I don't think, I can't guarantee that I can run Singularity on Ubuntu 16. But I can have an environment of CentOS, Arch Linux, or any other setups, Linux-based, unfortunately. If you wonder that if you want Windows running Singularity, I think you are out of luck. Similar for Mac. But the idea is that you can think that you can have a live USB and you have a computer, which is the university computer and doesn't have all the tools you want, but you plug this USB to the computer and all of a sudden this brings or exposes your files to an environment you have created on this USB stick, which will give you all the tools that you have built, collected, compiled, and etc. You can pull that stick and put another one, and the same files that you have on the computer all of a sudden can benefit from something that you installed in another container, etc. This is vastly utilized by tools like SnakeMake and NFCore. Literally, it goes so bad that they have containers, only container for bash, because they want to run bash scripts and they don't want to even doubt that somebody is running a machine with incompatible bash or anything, etc. So they are just running even bash scripts in containers that they provide online. With that one, I told you that the material online is not linear. It means to cover these four topics: building, running, pulling, and a little bit of details. And because over the years we had multiple questions which are inevitable. At some point you want to build. In practice, you're running quite fast into a problems. So I have like a case. We have collected case studies. You can look here for different approaches, but we will not talk about them unless we reach something relevant. So